Okay, we're now going to begin the main material for the course. Some of this beginning material may be a review for some of you, but that's okay. Just follow along and make sure to do all your work. This first set of videos we're going to be looking at are going to deal with equations, inequalities, and mathematical modeling. So let's just get down to it. This first video we're going to talk about graphs of equations, and then we're also going to talk about x and y intercepts. Now, the most basic way that you probably learned how to graph something is using what's called just the point method, where you have an equation, and let's just dive into here. So we have an equation, let's say y equals x squared minus 3x, and we want to graph it. So graph the equation using the following values for x. And what I mean here, well, I haven't finished writing out the problem completely, is I'm going to give us a little table here. And this table is going to have x and then y, and I'm giving us the values for x to use. So we'll do -1, 0, 1, 2, and then 3. And now we have to figure out all the y values, and once we figure out the y values, we can then sketch what this curve looks like. Now, to figure out the y values, we're literally just going to use the equation we have here. So we have y equals x squared minus 3x. And so for -1, we simply, whoops, managed my hand to get this all boogered up here. Sorry about that. Alright, there we go. So, don't know, I'm using a tablet with a pen, and my hand accidentally moved the screen all over the place. Alright, so let's get back ahead of here. We've got x, -1, 0, 1, 2, and 3, and we want to find the y values, and then we're going to plot this to sketch the curve. Alright, so the y here for -1, we had simply substitute in -1. Now you're going to notice that when I substitute things in, I'm always going to put them in parentheses, or a majority of the time, and that's so I don't mess up with negatives. So I have -1 squared minus 3 times -1, which would be 1 plus 3, which is 4. And so this y value here is 4, and then if y equals 0, or I'm sorry, not y, if x equals 0, you'd have 0 squared minus 3 times 0, which is of course just 0. And then if we have 1, we have y equals 1 squared minus 3 times 1, which this would be 1 minus 3, which is -2. And then we have y equals 2 squared minus 3 times 2. So this would be 4 minus 6, which is also -2. And then for 3, we'd have y is equal to 3 squared minus 3 times 3, which is of course just equal to 0. So we have 0 here, and this one was -2. Alright, so we have our table with our points. Now we're simply just going to plot these points on a graph. So I'm going to go ahead and make a graph here. Sketch a graph. And so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. We'll go ahead and go up to 4. And then we'll only go down to 2. Alright, so I'm just going to go ahead and plot these points. And so -1, 4, well, that would be -1 all the way up to here, so that's this point right here. And then I have 0, 0. That's that point right there. And 1, -2, so that would be right here. And then 2, -2 should be right there. And then 3, 0, which would be right there. Now, we have to sketch a curve through these points. Now, we need to know, well, what would this be? Would it just be simply, connecting the dots? And of course, it's not just connecting the dots. This equation was x squared minus 3x, and you might remember this has a shape of what's called a parabola. So I'm going to do my best here to sketch it. It's a little bit challenging sometimes on the tablet. So it would roughly look like this, is what the sketch of the equation would look like. Alright, so you could sketch more by plotting points, but I think one example is enough to kind of refresh us. As far as what points to choose, well, some of that just takes practice to get to know, but a lot of the problems specify the points that you would use in order for graphing. Alright, the other thing we want to talk about in this video is x and y intercepts. And then let's go ahead and write down here. I'll abbreviate intercept with int, x-intercept. This is a point on the graph that touches the x-axis. Or you can think of it as a point on the graph that has y equals 0. And you can think of it that way just because, well, y does equal 0. If you're on the x-axis, what's the y value? It's 0. And similarly, you can think about a y-intercept here. This is a point on the graph that touches the y-axis. Or you can think of it as a point on the graph that has x equals 0. So let's just go ahead and look back at this example, and we can see here, this point right here, this would be an x-intercept because it's touching the x-axis. Or if you think about what it is, that point, the y value of that point is 0. Now this point right here, of course this is what's called the origin of the axis, it's 0, 0. This is both an x-intercept and a y-intercept. Why is it both an x-intercept and a y-intercept? Well, it's touching both the x-axis and the y-axis. Now this is the only point that can both be an x and y-intercept. Otherwise it's just an x-intercept or a y-intercept, but in this case we have it being both an x and y-intercept. Alright, so let's talk about here finding x and y intercepts. To find an x-intercept, we set y equal to 0 and solve for x. And we can just look at the definition on why that would make sense. Part of our definition says it's a point on the graph that has y equals 0. So if we know y equals 0, let's set it equal to 0 and then solve for x, because those are going to be the values where y is 0. And you can kind of guess maybe to find a y-intercept, it's going to be almost the same thing. So to find a y-intercept set x equal to 0 and solve for y. Alright, so let's look at an example or two here. Let's go ahead and find the x and y intercepts of find x and y intercepts of x cubed minus 4x. I should also say this is equal to y. Okay, so I'm going to find the x and y intercepts of this. So let's first find the x intercepts. So we set y equal to 0. So I'm going to have x cubed minus 4x equals 0. Then we want to solve this for x. How do we solve this for x? Well, one of our review videos that you could have looked at kind of talks about it briefly, but it's factoring. We have to factor this in order to find what x is equal to. Well, the first thing you want to look at here is x cubed and 4x. We could factor out an x from both of those. So you'd have x times x squared minus 4 equals 0. Now you want to factor this all the way. So x squared minus 4, remember that was one of the special products, special factor rules. So this actually factors to x times x minus 2 times x plus 2 equals 0. Now, the way we solve this then is it's a very special property of algebra. It's called the zero product property, meaning that if you have terms multiplying to 0, one of them has to be 0. And so what we can do then is we can write this essentially, there's three options here. Option 1 is that x could be 0. Option 2 is that x minus 2 could be 0. Option 3 is that x plus 2 could be 0. So you would write x equals 0. I always like to put or. You don't have to. X minus 2 equals 0. Or x plus 2 equals 0. And then you solve each one of these. Now this one's already solved, x equals 0, this first one. And then solving the second and third one are pretty easy. X minus 2 would just get you x equals 2. X plus 2 would just get you x equals negative 2. So then the x-intercepts are 0, 2, and negative 2. Now I want to emphasize here the points or the coordinates of the x-intercepts are, well, we have 0, 0, 2, 0, and negative 2, 0. And of course, we know that the y value is 0 for all of those pairs because, again, that's the definition of an x-intercept. Well, y-intercept for this is going to be a lot quicker to find. We simply have that we set x equal to 0 and solve for y. Which is pretty straightforward. We have y is equal to, I'll rewrite the equation down here. We have x cubed minus 4x. So we're going to substitute 0 in. 0 cubed minus 4 times 0. So y is equal to 0. So that's my y-intercept. So the coordinates for y-intercept is 0, 0. Now, we shouldn't be surprised that we're getting that as a y-intercept because we had that in my x-intercepts. And remember, 0, 0 is the origin, which is the one special point that's both an x and a y-intercept. All right, let's look at one other quick example here. And let's look at the equation y equals 1 over x squared plus 1. And we want to find the x and y intercepts. Well, just as before, to find the x-intercept, we set y equals to 0 here. So we have 0 is equal to 1 over x squared plus 1. Now, we have to think about this for a second. First off, if we think about this, I can put any number in the denominator here because I have x squared. If I put 0 in here, I have 0 plus 1, which is 1, and then any other number is going to be positive because I'm squaring it, and I'm going to be adding 1. So we're okay putting any number in. But now I have to think to myself, is there any way I can get 0? Well, if you have a fraction, remember you can never divide by 0, so anything that makes the denominator 0 isn't going to give you a valid answer anyway. So for a fraction, it's like, is there any number we can use for x to make numerator 0? And of course the answer here is no, because there's no x in the numerator. The numerator is always 1. So all this means is that we have no x-intercepts. So I like this one just because, again, you don't have to have x-intercepts. Alright, well let's now talk about the y-intercept. So the y-intercept, well, again, we set x equal to 0 and solve for y. So I have y is equal to 1 over 0 squared plus 1, which would just be 1 over 1, which is 1. So my y-intercept is 1, and the coordinates for the y-intercept are 0, 1. Now I'll go ahead and do a rough sketch of what this graph looks like. We're not going to sketch it with points and everything, but I'm just going to give you a rough sketch so you can see that our answers do make sense. So I'm going to go ahead and just make this point here 1. And so I'll put a point right there. And then the curve looks something like this. And so we can see here, yes, it's got a y-intercept of 1, but then you can see what it's doing is it's going down and it's getting closer and closer to the x-axis, but it actually never touches the x-axis, and it does the same thing on the right-hand side. So from the sketch we can see that there's no x-intercept.